And then don't worry about that. It's about the how to check the one. I could try to show you today, but okay, let's try a question. I got a poll question here. Yeah, it's a hard question, right? Uh, okay, so there's people choose the right answer. Okay, I'm gonna end the poll and show you the result. The right answer will be the mercury battery. So that's the right answer. The mercury battery will be the right answer. And please remember that. Okay. Yes, no. First, there's a field is not a primary battery. So the right answer will be the mercury battery. They usually, even when they're doing their discharge, the output voltage is always hold constant. Okay. Just because you guys are all here on time and give you an extra hint. Okay. Any question from yesterday? I know probably forgot to open the online quiz, but thanks for reminding me. I think someone yesterday reminded me. I said, oh, I remember I opened, but apparently it's not. Question? No? More? Let's see if you guys want to watch the video. No, it's not a video on my part. Hey, it is. Oops.
In this video, we're going to demonstrate how to perform a load test on a battery using only a multimeter. In order to do this, you have to have a multimeter that's got a min-max function. As you can see, the min-max button there indicates that this meter has that function. So initially, we'll turn the meter on to the
see the video, Jack,
and connect the leads to the battery. And we want to make sure that the
you cannot see the video?
No, okay. Couldn't see it. No.
Okay, I probably choose the wrong one.
In this video, we're going to demonstrate how to perform a load
Can you see now?
Yeah.
test on a battery using only a multimeter. In order to do this, you have to have a multimeter that's got a min-max function. As you can see, the min-max button there indicates that this meter has.
Oops.
In this video, we're going to demonstrate how to perform a load test on a battery using only a multimeter. In order to do this, you have to have a multimeter that's got a min-max function. As you can see, the min-max button there indicates that this meter has that function. So initially, we'll turn the meter on to the DC voltage setting and connect the leads to the battery. And we want to make sure that the open circuit voltage, or the voltage available at the battery, is above 12.4 volts. 12.4 volts indicates that the battery is at least 75% charged, and that this test will give us some meaningful results. If it's below 12.4 volts, obviously the battery needs to be charged before this test is performed. So we can see that this battery is at 12.6 volts. It's 100% charged. So we'll push the min-max button to begin recording, and we'll start the car. Now what happens is when the starter first begins to spin, it draws a lot of current initially, and that during that initial inrush of current, the voltage will be pulled down, and we want to measure what the lowest voltage is during that time period. And as long as it's above 9.6 volts, this battery's got sufficient capacity to start the car. If it's below 9.6 volts, 9.6 is the magic number. If it's below 9.6 volts, this battery fails the test. So go ahead and start it, and we'll let it run for a few seconds and shut it back off. Okay, so now we come back over to the multimeter, and we'll push the min-max button to scroll through the readings. The first reading is the high reading, 14.68 volts. That indicates that the charging system is working. The low reading is 9.96 volts, which is above the 9.6 volt minimum, so this battery passes the test. It has enough capacity to start the car. Again, if it was below 9.6 volts, it would fail the test, and we would either have to recharge and retest the battery, or we would condemn the battery, depending on the situation. That's how you test a battery using only a multimeter.
Did you guys see it okay?
Yep.
Okay. Oh. Too bad. Any question from yesterday, or should we just keep going? No? Oh, I guess I get a really good group. Everyone's okay. So yesterday we talking about the battery. Today we're gonna talking about the battery charging system. No, 12.6 is the one what he did in this video. So maybe his battery is charged to that. Yeah, so 2.2 volts per cell is I think that's the right number, just like I showed you yesterday in the PowerPoint. A fully charged 12 volt lead acid battery, you need you should read 13.2 volts. That makes sense, correct? Yeah, his battery just in a car may not be fully charged or been using for a while. It's aged battery. Yes, 2 volts per cell is the standard number. So you will consider a 6-cell battery have 12 volts. That's why we call the battery is a 12-volt battery, or we call the battery is a 6-volt battery, which have a 3-cell. Or if you have a 24-volt battery, which will have a 12-cell. But when you fully charge your battery, the battery's voltage will go slightly higher than that. So if we ask you to calculate, we say, okay, like yesterday, I gave you a sample. I said a 30-volt battery, how many cells you need? You just use 30 volt divided by 2. But if they ask you a 12-volt battery, what's the fully charged battery terminal open circuit voltage? You will answer 13.2 volts.
Would we get any questions where they say like, okay, you have a 6-cell battery and then you have to assume it's 12, or would they like describe it more than that?
They will say, okay, a battery measured, let's say, this if they say the battery measured 20, let's say 22 volts, right?
Yeah.
When they fully charged, then they can ask you, okay, how many cells inside? But usually you will not get those type of questions. They will just give you the standard voltage reading. They will say, okay, a 20-volt battery, 24-volt battery, how many cells you need? Or a 20-volt battery, how many cells you need?
Okay, thank you.
Yeah, the only one they're gonna ask you is a 12-volt battery. When they're fully charged, what's the voltage? What's the hydrometer reading? Or fully discharged, what's the hydrometer reading? Or you woke up late in my class, join my class late, there's gonna be some kind of punishment waiting for you. It's okay. Yifan, you got a question 31? In working sheet or where? Okay, just give me a second. It's the online working sheet? Oh, okay. Yeah, then we can talk about that after class. Or maybe when we just remind me later. So, hope okay now. I still want to see the chat down here. Okay. So first, I'm gonna give you some reminding questions. Compared to a fully charged lead-acid battery, the indicator floater in this hydrometer will be in what kind of state in a discharged lead-acid battery? So you can see here's the green, here's the red. That is fully charged. This is fully discharged or discharged battery, right? So if we go back to the page before, when it reads red, which means the battery is discharged. Only when it reads green, which means the battery is fully charged. And this thing we showed you yesterday, it's just like this one. It's a floater in there. So the higher your green is somewhere here and your red is there. So when it go sinking deeper, which is the red part. Oh, lots of people choose D. Okay, this is a cylinder cell. It's a dry cell, like a primary battery, which is the large size in here. Hello, anyone there? So, yeah, size D is the largest size, right? Because they usually AAA is the smallest one, AA slightly larger than that, then C is larger than AA, and the D is larger than C. So you probably should give me the B because it's a multiple choice, or you can say size D, right? Okay. This type will be pretty common question on your exam. 12 4.6 volt cell connect in the arrangement show. What will be the bus voltage made with this connection? So here's your bus. Yes, D will be the right answer. It's a 4 in series. Good. Before I go further, so on the D2L, you guys have this working sheet, the battery connection and the answers. Take some practice for that, and you will get a similar question. So make sure you can do those type of question. Even it's maybe just one question or two question, but every mark worth to get it, right? Okay. So when you recharge your battery, you need to put a DC current in the reverse or opposite direction to reverse the chemical reaction. But when you're using a charger for a battery, there's a bunch of things you have to consider. You don't want to overcharge it. You want to have the proper way or method to charge the battery, and you want to preserve the maximum life of the battery. So the voltage and the current, and for how long, and if the battery using in different kind of application, are you gonna keep the battery in fully charged state? All those things is being considered when you're picking a charge. If you buy the charger and the battery from the same manufacturer, they usually they will give you some kind of recommendation, or they will either supply you with the battery and the charger. That will be the most easy way to do it. But if you try to pick those in yourself, you got to be somehow be careful. You don't want to. You have to look in all the specifications to make sure you don't damage the battery, or you don't shorten the battery life by using the wrong chargers. So that when you first start charging, the battery usually can with a higher current, and because when the battery is at a fully discharged state, you try to bring the voltage up, bring the capacity up faster, so you use a higher current. But once the voltage and the capacity reach certain level, you want to reduce your current, because otherwise you might cause overheating, or you might damage the battery. The charging method also depends on different type of the battery. So here's a few things, as long as you follow, but mainly those is for the manufacturer or for the engineer to picking up the certain type. They call it do not generate excessive gassing. Like we know lead acid battery, when you're charging them, they're gonna release the hydrogen gas. Or do not overcharging them, do not cause the high temperature to happen. It's a certain type of application you can monitor those things, but a certain type of application, if it just I threw you a battery and a charger, I ask you, okay, you go to monitor those things. You don't have the proper equipment or proper information. You will consider what is considered to be excessive gassing, what's considered the high temperature, what would be considered overcharging. So unless you have all the information, that's really not easy to decide. So the best way is just get the, when you buy the battery charger, they usually have some type of recommendations. They will say, okay, what type of the battery can go with this charger, and what's the capacity, because your battery charger, they usually have a voltage, we have a current limiting on there. But in here, for us, we just need to know certain type of the, we're not gonna go to a real application. We just going to explain something commonly used by the battery charger manufacturer. There are different type of charging. One called the initial charging. This is the first time secondary battery, we know it's a rechargeable battery, is charged. Once you added all the electrolytes to the battery, then you can start charging it. They consider the first time you charge it, you don't use very high current. They said they use a pretty low current to properly form the plate to initially charging the battery. A normal charge is a routine charge for a battery. So once you start using the battery, and when you discharge it by low, you're going to properly charge it. The charging current will starting high and gradually fall off when the voltage rises. Without those modern microprocess control, you'll have to be watching the time and charging voltage, charging current to make sure there's no overcharging. A normal charger, it's not going to be it's not commonly used anymore. It's mostly now the chargers with the process or microprocess built in, or they have a bunch of electronic circuit built in there to make sure. Those one are not on your slide. Give me a second. Let me take a quick look. I would upload this one. It's there's another PDF, right? Okay. Yeah, there's a guys looking for multiple one. So it's not very common. You can just buy. Let's say you have those cell phone chargers, all those chargers. They will inside the charger. They will have those things. They will monitor what gonna be when the battery is fully charged. They barely gonna causing overcharging situation happens unless you have a really old charger. This is another one. This one still you probably can buy from some of the place. It's called a trickle charger. They are using for if you have a battery, let's say, especially now you have those because the pandemic, you're not driving around too much. Some people just stopped their car for even stop the insurance. They just parking their car in the garage or in the driveway. If you're parking your car for there for half a year or 8 months, 10 months, the battery inside the car, they will slowly discharge itself. So people will using one thing, especially if you have an older, even a motorcycle in storage, and they will use a trickle charge to try to top up the battery to keep it fully charged. But it depends on the price and the manufacturer or how advanced those will be. I heard people said they bought some really cheap one, and you have to watching it. You put on for 8 hour or 10 hour or 12 hour. You have to remember to take it off. That's because they don't have those monitor function or something inside. But if you bought a new one, advanced one, or they have those advanced technology inside, you probably don't need to worry about it. You can put on there, let it finish the job. Once it fully charged, then you can just take them off. So did you get a good one, or did you get the one you have to watch it yourself? Yeah, the good one is a little bit better because you don't need to worry about it's overcharged. Otherwise, I sometimes heard people just say, oh, they actually damaged the battery because they forgot to take it off. Then I thought, just by saving that little bit of money, it's not worth it. Because a battery is much more expensive than those chargers. The trickle charge type is they give a low constant current. So they're now gonna put in output a very high current. And when you use those, you cannot with no external load connected. They mostly used to top out a battery. This part is depends on, I think by looking at the smaller one, they probably have to manually disconnect to prevent the overcharge. But the good one, especially as the technology advances, lots of things become less expensive. So floater charger. This is a low current battery charger. Usually is at end of when you fully charge the battery. You just your battery is sometimes you use a little bit, but you're not constantly using it. So a flow charger can keep the battery topped up. We keep the battery in the fully charged state. But this floater charger, there's a one important feature is the battery and the load will be connected in parallel. So the flow charger, you can connect your battery, but if you want to use the load, let's say you want to use the load for certain type of application down here, so you can drain the power or drain the energy from the battery, but at the same time, the flow charger is connect on there. They will still keep charging the battery. So this part is very important, and it's kind will be a main feature to identify the charging type. So if they're talking about battery and the load is connecting in parallel, that will indicating they are using the flow charging. Yeah. So if you are flow charging it, you are you can disconnect, you can discharge the battery at the same time you try to use this charger to charge the battery. They are connecting in parallel. So battery and the load connecting in parallel. And this one for sure gonna be a modern microprocessor control the charger. They will have sensors. They will monitor the battery voltage to say if the battery is fully charged or not. And once the battery is fully charged, they will automatically shut off, not gonna be causing overcharging. And if the battery, you've been using the battery, or if the battery being stay there for a certain months of the time, they discharge to a lower value, the flow charger will automatically come on to try to start charging the battery again. So they never we cause an overcharging problem, and you can connect them with the battery all the time. This picture we're gonna talk in next one. It's much. Okay, so this is a kind of IP question. It's probably an old IP question. I don't know if they're still using them or not. Monthly maintenance of a battery bank would not normally including oh, now I can see the answer is everywhere. Yeah, I guess it's the B. Your monthly maintenance probably don't ask you to tighten the terminal with a crescent wrench. Yeah, you gotta check the level of electrolytes. You're gonna check the condition of the pilot cell. That's when the one we're talking about yesterday. Clean the dust off, but tighten with a crescent wrench. And you probably want to use an insulated one for that. And it's not going to be monthly you try to tighten it. Okay, so this one I changed it slightly, especially on the second one. The modern 3-stage charger. The most modern battery charger have 3 stages or phases to charge the cycle. The phase 1 or stage 1 is called a bulk charger. When they in bulk charger state, they provide with a higher current and a higher voltage. They use down deeply discharge the battery. As the battery will absorbing this charger, the voltage start rising. So this part is considered the battery terminal voltage, because after you discharge your battery, and the terminal voltage will drop lower. So you put a higher voltage. You usually, yesterday we talked about you need a voltage higher than the terminal voltage to charge the battery. So you put that high voltage and give a higher current to charge the battery, and the battery capacity will starting to rise, and the voltage will also rise too. Here they said for a 2 volts battery, because here we're normally talking about lead acid battery, the charging voltage usually does not exceeding 2.4 volts per cell. So if you have a 12 volt battery, you wouldn't go more than 14.4 volts. So you can go, yesterday I think we're talking about 13.6 to 13.8 to 14.4, somewhere down there. So you're not gonna over this number, but in this bulk charger state, you're gonna take in slightly longer time, because for a fully discharged battery, you need give that to bring the capacity back. So it also take a little bit of long time. So here the battery capacity, they will rising up, and here the current, you can see the charging current is pretty high, and the terminal voltage of the battery start rising, but your charging voltage is almost somewhere. That's the charger output voltage is somewhere there. Phase 2 or stage 2, that's the one I changed. On your PowerPoint, on your PDF file, they probably called a trickle charge, but the modern those chargers, they kind of consider called absorption charger. the voltage is still high. So even the voltage of the battery terminal bring up, they still are using a high voltage to charge the battery. The current start dropping, so they don't need to use a very high current like before. Depends on the battery's capacity, how full they are. They will gradually reduce the battery charging current. Because the current in stage 1, we already use to try to bring the battery capacity up. At this stage, once they reach about 80 or 85%, we can lower our current, try to bring the capacity to almost 95 or 100%. So that the absorbing charging stage usually take 2 or 3 hours, bring the battery capacity to almost like 95%. The third stage or third phase is called a float charger. So now, because the battery's capacity is almost 90 to 95%, and we don't need to use that very high voltage anymore, the voltage will also drop. So they now going to use that high voltage anymore. They drop the voltage lower. It depends different chargers. They will. It's this number gave it's just picking from one of the manufacturer's charger. So, but we know at this third floater charger stage, we don't use the very high voltage. You can drop this voltage to a lower level as long as it's higher than the battery's cell level. This will be connect on there forever. It can last for days or weeks. And the floater charger, like we talking about before, you can have the low and the battery in parallel. You can still keep charging the battery, and you can use the battery, no problem. They just try to keep the battery in the full, top up the battery in the fully charged state. And the current will also drop to minimal, because at this stage, you just need a little bit of current, slightly lower voltage to keep the battery fully charged. Here's something you need to know. To charge a NIC-cadmium battery, you have to use the constant current method. So if I ask you a question, I said, oh, what type of the charger or what kind of charging method is used for NIC-cadmium battery? You need to pick this one, constant current. Yes? No problem? Or someone just try to post that one onto the Discord. How many people we got here? 45. Are you truly all here? Okay. Modern chargers. Did you guys have this one on your PowerPoint or not? Because you guys this course material is copied from another one. I think it's not in. Yeah, I think you. I think another thing is you can just take a picture or maybe I will upload this modern charge, this PowerPoint onto the D2L, so you can have it. So in here, this is the something I added. The modern multi-stage charger, like the solar controller, especially those one, they are microprocess based and they can be set for specific application and the battery type. Box stage will provide desired current until a user preset absorbing voltage is reached. In absorbing stage, the charger goes to constant voltage mode and the current naturally taper off as the battery plate becomes restored and desulfated. This stage is usually determined by a user-defined time period, depends on the relative rating of the charger and the amp hour capacity of the bank. Continuous charge at the absorbing stage will excessively gas the battery and evaporate the electrolytes. Flow charger is a maintenance charger stage that maintains the battery, lower floating voltage level, minimum current to offset self-discharging, and supply power to parallel loads. If a power outage occurs and the load demands exceed the flow charger capacity, then the box stage is restarted and or when the power is restored. One more thing is called equalization charger. Equalization charger is used only initiated by maintenance personnel. It's not automatically. They use a higher voltage of the equalization stage may damage the sensible load, so they are disconnect from the battery bank. So when you're using the equalization chargers, you have to disconnect the load from the battery bank. So we're talking about flow charger, you can keep the load on there, but if you try to use the equalization charger, you have to disconnect the load. All the maintenance is performed before the equalization stage is initialized. Ensure the proper ventilations during the equalization stage. The equalization stage usually is try to reverse those suffocation anything. They try to bring the battery back to the original condition, original capacity. So they use a higher voltage and a higher current. They try to reverse those like the sulfur deposed onto the electrodes on the battery terminals. So for these two slides, you probably will not have them. I will upload this one onto the D2L. Electrical vehicle, sometimes called EVSE, that means service equipment. Sometimes called the electrical vehicle, they called EVC, CE, then will become electrical vehicle charging equipment. How long does to charge an electrical vehicle? I think this usually, they give you the typical time, and also depends on your battery capacity, and depends on the manufacturer, depends on lots of things. But this is just some common or typical value grade. This value is not a fixed number, so don't need to worry about that. As long as you know the different level, they will take a different time to charge the battery because they're using different current and the voltage. Level 1 chargers. Level 1 charger is using at home, usually is 120 volts, and in the home, a regular plug can supply 15 amps, and we even know more than that is a 15 amp circuit breaker in your house. It can only continuously supply 12 amps, right, to 80% of that. It slowly charge your battery. Here is some of the car. You have those type of connector in your cars, and this is the plug into a normal receptacle. Here the charge controller down here, and that's the end plug into your car. That's the level 1. Level 2, usually depends where you're using them. If you're in an apartment building, you have a 3-phase supply, you will buy a 208 volts. If you're using in a single dwelling unit, you have a 240 volt supply. You're gonna buy one with 240 volts. So when you buy level 2 chargers, you gotta be careful. Depends where you live, you will using different one. But most of the people, they will only buy them to install in their single dwelling. So they will buy the 240 volts, but the 208 volts is also available down there. Level 2 charger, usually the current is between the circuit, they require 40 amps circuit or 40 amp circuit breaker, but sometimes they will only draw around 30 amps because a 40 amp circuit breaker load to 80%, you can draw about 32 amps. So the actually charger is taking about 30 amps, but they require 40 amp circuit breaker. So the power required will be higher, and they will require less time to charge in them. Level 3, they don't have. I don't think they have a standard there yet for across all the manufacturer. I think Tesla has their own standard. Other electrical car company have their own standard. So they use a high DC voltage to charge the car directly. Level 1 and 2, they use AC. They have those charge controller. They're gonna have a rectifier to convert into DC. But the level 3 is they require directly DC. The voltage depends on the manufacturer. Someone use 440 volts, someone use 480 volts. The current, the one at the BCIT there, they can supply 100 amp DC current, but they are much more expensive. You're probably not gonna buy them to install them in your house. It's usually commercially installed around the highway. Okay, another IP practice question. Creating electrolyte using full strength sulfuric acid and distilled water. How should you mix those ingredients? Oh, good. So you guys are all paying attention in my class yesterday. Good. That's a very good thing. So you will get this question right, no problem. Basic charging circuit. We're going to show you a few basic charging circuit here. The charge, because the battery need a DC to charge it, so you can use a half-wave rectifier, you can use full-wave rectifier, you might use a resistance down here to limiting the charging current, you might use a capacitor there to filter out the ripples or filter out the pulsating DC into a smooth and constant DC. So half-wave rectifier or full-wave rectifier, both okay. The more advanced one, we use full wave because half wave you're wasting half the power. Because your input usually is AC with high voltage, and your battery usually is at the low voltage. So they will first step the voltage down, use a transformer, then they're gonna have the rectifier on the low voltage side. The simple one, you have to monitor, make sure no overcharging, and the controller is also manually monitored. Regulated battery charging circuit. In this circuit, once the battery is fully charged, the charging process, we cycle to maintain a trickle charger or floater charger stage. So this piece of charging circuit is also an important piece. You will be asking. There are gonna be questions asked you relate to this charging circuit, battery charging circuit. They will ask you, oh, what's the purpose of this component in this circuit? What's the purpose of that component in this circuit? The later slide, they will give you a bunch of indication. But here, I'm just going to be give you a quick and explanation. AC is a power coming in, a transformer to step the voltage down, and then you have a full wave rectifier down here. You have SCRs, SCR1 with R1 is in series. They are directly across the battery terminal. Here the battery were used for charger. So R1 is try to limiting the charging current to where this battery requires. The SCR1 is SCR. In level 3, you learned the SCR need a triggering gate signal to trigger it. So this is a 3 resistor in series. They are building a voltage divider circuit here. This potentiometer on here is try to setting because you can move this potentiometer to controlling what gonna be the voltage on the battery here to stop the charger. So if you want to bring this voltage a little bit higher, you move this potentiometer up. If you want to make sure the fully charged stop the charger a little bit lower, you bring this one down a little bit. So this is for controlling the charging voltage down here. We have a Zener dial here. The Zener dial in this circuit is controlling when, if this battery charging to the certain voltage down here, once this terminal for this potentiometer reach that voltage, the capacitor down here is for filtering to stabilize the voltage across this Zener dial. Once this voltage reach the setting down here, they will cause this Zener dial to conduct. When this Zener dial conduct, because we can see this Zener dial is in reverse biased direction, and the Zener dial working in that way, right? So once this one conduct, it will send a triggering signal to the gate of SCR2. If this voltage is not reaching the rating of this Zener dial, the SCR2 we not have a gate signal to trigger it. So SCR2 is blocking. When SCR2 is blocking, for this 2 terminal on this bridge rectifier, this one we have a higher voltage level than the cathode of this one. So when SCR2 is now conducting, the D5 is the forward biased. D5 is forward biased. You will causing a triggering signal sent to the SAR1. We causing SAR1 to conducting. So that's going to be a current go through here to charge the battery. And depends on the battery voltage level, this voltage divider, we have a different voltage dropping across it. But once the battery charging to the required value, it causes Zener diode conduct. The Zener diode conduct going to send in a triggering signal to SAR2. So when SAR2 conduct, you will have a current go through SAR2. The voltage drop across the SAR2 between anode and the cathode will drop to very low. So when this voltage dropping low, the D5 is now gonna be, because the cathode on here is connected onto the positive terminal of battery. So D5 is now gonna be forward biased. This gate become reverse biased. So there gonna be no triggering signal to SAR1. So the charging gonna stop because SAR1 gonna block. So once SAR2 conduct, it will stop the charger. If SAR2 is not conducting, the triggering signal will send to SAR1, you will start charging it. What's the voltage you want to charge this battery to? It depends on this potentiometer, the setting down here. So this is for controlling the potentiometer, for controlling the charging voltage, to fully charge the voltage for this battery. This is a big piece of drawing, and here have a, did you guys have this on there? I will upload this one on there anyway. So you better read this one, read this piece of drawing. You need to understand what's the purpose of each component in this charger circuit. So you will encounter some questions. They might ask you, oh, what's the purpose of this SAR1? What's the purpose of this Zener diode? Or what's the purpose of this D5? So this one gave you a pretty good explanation. One more thing is, if we look at this big one, can you label the terminal or the polarity of the component, let's say, because we use the bridge rectifier to converting AC into DC, but which terminal is negative, which terminal is positive? Will you be able to do it? Not likely. So yeah, you can trace it from the battery. Also, you can say if the top is positive, the bottom is negative, we know the current gonna go from here to there and go through this one, go back there, right? Or if the top is negative, bottom is positive, your current will go through D1. And go through D4. So this terminal is always positive. This terminal is always negative. Yeah, so the terminal connection between D1 and the D3 is always negative. The terminal connection is all between here, is always positive. I'm using the electron current flow. The way I think is because of since year one, you guys got taught electron current flow. So even in the electronics, I always try to keep the electron current flow. So if this is negative, anything connect onto this terminal. When you try to label the polarity of each component in the circuit, you always do is, let's say for this R3, the R3 have two terminals. This terminal, you just ignore any other component. Is connect close to this terminal or is connect to close to this terminal. So the top for sure is close to that one, so top will be positive. The bottom is close to here, so bottom is negative. So just be careful. They might ask you maybe in the charging state or maybe in the fully charged state, what will be the polarity of those components down here. Okay, so that's one thing you need to be able to tracing them out. Or you can just using the battery polarity. Okay, here's the thing. You guys are okay to label this, or you want me to give you a drawing to label it? Nobody like talk to me? You are lost? Give me a second. Let me see. Just give me a second. Let me see if I can. I'm just going to do an easy way down here. Transformer. Okay, my drawing is not perfect, but so this is your negative terminal. This is your positive terminal. So for each component, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. Uh, that's good. You can take a screenshot. You guys still with me or no?
Yep.
Okay. So it's not a perfect drawing because I probably not gonna have enough time for me to find a drawing software to try to label this one, but it will work with this one, right? Yeah. So once you guys take the screenshot, I'm gonna go back to that. So let's see if for this battery, the setting here, I want this battery charging to 13.2 volts. Once this battery reaching this 13.2 volts, these three resistors we have a different voltage drop crossing. So they didn't give you the value. Maybe because let's just say where you get this potentiometer here, if this one reaching 13.2 volts, this potentiometer here will reach 6 volts. So once this one reaches 6 volts and you have a Zener dial, it's rated for 5.8 or 5.9 volts. this 6 volts is higher than this side because this one is connected to the ground and this one is now conducting. So this terminal is very low. So 6 volts is higher than the Zener diode's rating. They will causing this Zener diode to conduct because this C1 we keep this 6 volts pretty constant. Once this Zener diode conduct, it will send in a triggering signal into SCR2. So SCR2, the anode is connected on the positive side, the cathode is connected on the negative. So SCR2 gonna conduct. When the SCR2 conduct, the voltage across SCR2 will drop to close to 1 or 2 volts. So the terminal here, the D5 here, on this terminal, will drop to 2 volts. But another end, this anode here, this cathode here for SCR1, you already reach 13.2 volts. So D5 will become reverse biased. When D5 become reverse biased, it's gonna stop triggering SCR1. So SCR1 will not have any triggering signal in there. The SCR1 gonna stop conducting. So there's gonna be no current coming from the charging circuit into the battery. Because we have a bridge rectifier here, we have AC, that's why here we got a pulsating DC. So this one will go through 120 times to, you need that triggering signal 120 times to trigger the SAR. If because the SAR, when this pulsating DC, the voltage reach 0, you're gonna stop triggering we call the commutated SAR. So SAR not gonna conducting, but as long as SAR2 is not conducting, you're gonna send in that triggering signal into this SAR1 to trigger it to keep charging the battery. That makes sense now? Yeah, in charging stage, D5 have to be conducting. Then once you fully charged, because SAR2 conduct, so D5 will not be conducting. Yeah, SAR, you always have to put them into, because SAR kind of like a dial, you have to put them into forward bias direction. Okay, one more question I want to ask you from this drawing. What if I have an opening circuit between this potentiometer and this Zener dial? If I have an opening circuit right where my mouse is, what gonna be the consequence of this charging circuit? Yes, so you won't stop the charging because you're never gonna trigger SAR2, and you're gonna keep continuously try to charge in the battery. You might causing overcharge. Good. Yeah, you guys are good. So this drawing, I probably, you guys have it, and when I upload this PowerPoint, you will have it again. You guys want to take a break, or you want me to keep going? Break? Okay, we're gonna be back at 9:35. So safety and maintenance. When you charge, especially lead acid battery, we release the hydrogen gas, so you have to make sure the area where you charge them is well ventilated. Verify the charge setting, connection to the battery are secure, and make sure polarity is right. Check charging cable for damage. Preventing overcharging and preventing undercharging. Also, you try to avoiding charging in temperature higher than a certain degree, because your charging already gonna be creating heat inside the battery, and if your ambient temperature is also pretty high, then you're gonna have a problem. Okay, so I think if I answer your question, Shane. Okay. Battery installation. Because industrial using, you have a lot of batteries and you have to follow certain rules. In section 26 of the electrical rule code, they will give you certain guidance and the requirement. You have to follow those. And the code we were talking about, I believe, maybe we'll finish all those. We are doing the battery charging now. Depends how far it goes. If we couldn't do this afternoon, we probably can do tomorrow morning. Location of the battery bank. So certain rules require you have locked doors for authorized person only, and you can see the ventilation pipe down here. They try to take the hydrogen gas caused by the battery charging out, and they try to circulating new air in there. Battery racks, because the battery is heavy, so those racks have to be able to hold the weight. It's also because the battery sometimes you will causing split of the sulfuric acid, so you have to be somehow protected against the corrosion. Also, you need to put the battery, have a space 10 millimeter between them. It's to dissipate the heat. Yeah, I will upload this one once I finish this one. Also, those racks usually it's bolted to the ground because for the stabilize, and sometimes if you have a concrete walls, you're probably gonna put an anchor into the wall because you want those one be secure. Sometimes they even have those seismic requirement, just like when you guys mounting a transformer, you have to not the direct mounting. You also need to have extra for seismic purpose, right? Connection. between the battery, usually made to suitable size bus bar or cables. Identification, the red is the positive, black is the negative. Wiring in the zoom have to be in a dry location. There's a bunch of rule we mentioned about that. We talk about when we get to there. So here is we're talking about battery chargers and the unit equipment. It's a smaller thing and you don't need to pay too much attention. There's a few code rules regarding that we're going to talk about. But if you want to know more, the unit equipment is those like an emergency for a building or for a place. They don't have the backup generator or UPS supply. They usually use the battery powered either exit lights or emergency lights. That's considered unit equipment. Think that's it for this one. Yeah, so just give me a second. I will converting this into PowerPoint. This PowerPoint is saved as PDF. Oops. Okay, white converting. I think Yifan, you said you have a question about working sheet question 31. Which working sheet? Quiz 1. Okay, take a look. Is it in the quiz or in the session 1 handout? Okay. Easy power. Quiz 1, question 31. This is the one? Okay. Let's take a look. 6 cell in question 30. So a cell have a EMF 2.2 volts, internal resistance 50 milliohm, and connected low resistance 950. What's the current in the circuit? Okay. So each cell, we will have a 2.2 volts and 50 milliohms, right? 6 cell was series connected to the same load. So pretending that's 6 of them. I'm gonna now join all of them. And the low, 950 milliohms. So the voltage is 2.2 times 6, 13.2. The internal, R internal is 50 milliohms times 6, 300 milliohms. Because for question 30, each have a cell have that, the internal resistance is that. Let's see. So the low, 950 milliohm. The total will be 3 plus that, give you 1.25 ohms. Yes, because in question 30, they're talking about each cell. Then question 31, you're going to have 6 of them. Now everything's good? Okay. Okay, I already got the file. Let's see. So I uploaded the PowerPoint as a PDF file, also in, I think in the battery charging. It's the one at the bottom, emergency power system battery charging. So this one should have all the slides inside. Okay, let me see. Because some of the picture the instructor makes this PowerPoint, he might be taking from the online picture, and the online picture it's sometimes hard to see because he might pick the picture is let me see, charging. Discharging. So charging slide in which one? The one we just go through? That as a battery type slide. Oh, yesterday's one. Okay, let me find that one first. You mean this one? So this picture probably taken from an online picture or from a book with this probably, let's say, is using the conventional current flow. When they thinking about discharging, they probably thinking the current go from the positive, follow this arrow. I don't know where that came from. Then go to here, you can see the arrow is from this one to there. And then when they go to charging, they actually go reverse. They go this side to that side. So these two picture is following the conventional current flow. But in here, we are using the electron current flow. So the direction is opposite to this. Yeah. That's one strange thing is we are in this electrical trades. The electrical trades is the almost the only one, or any book we try to use the electron current flow. Even like it's a common agreement now because we all agree the electron can move and that positive holes cannot move. So we know the current is flow by causing by the electrons. But most text, like academic book, most book they're using by electrical engineering or electronic engineering. They still using the conventional current flow because for them it's been so many years and all the books is writing that way, and the arrow, everything, like the electronic components, especially those arrow in the conventional current flow is indicating the current direction. But now we suddenly, our trades is the only one we actually changed. But because you guys was since year one, you got taught the electron current flow. So I will try to keep that way. when I make something, I always try to be careful or make sure it's following the same direction. But some of the book you get or some of the online picture, they might using the conventional current flow. But at the end, I think also, what should I say? In our trades, you will sometimes got the question ask you to label the polarity of the component, or in year one, you will get asked to label the current direction in a circuit. In other, let's say you go into an engineer course, they never ask you to do that, because doesn't matter which way the current flow. Once you have a current go through a load, you will generate power, you will causing the circuit to work. So that's the point of view from their point. They just think it's always been that way. The people from their school is always learned that way, so they keep teaching that way. So for us, doesn't matter. We just keep following the electron current flow. Yeah, sometimes if you're looking some online video or online pictures, they might have they might causing some confusion. So basically in here, what we're talking about is if you have a lead acid battery, so because it's the two terminals, negative, positive. If we have a low here, this is the low. So that will be our complete circuit. We are using electron current flow. So we're going to consider the current direction is this way. So they go through the low in this direction. This is a discharging. Then if we want to charge it, we're gonna use source. And this is negative terminal, positive terminal. But in this case, the source going to try to push the current go this way. So this is the charging. This is just an opposite direction for the current flow. So I think, John, did that answer your question? I think you asked a question, recharging go into reverse. Okay, yeah. So that's just if we're using electron current flow, we just follow this way. Okay, I think we finished this charging, and we're gonna go into next one. I uploaded a PowerPoint onto the D2L. If you guys want, you can check that. So we're gonna go to the generator. In certain application, and because the hydropower, sometimes the hydro we have a problem, and sometimes people driving a car hit the hydro poles, or hydro have to do a shutdown maintenance. For certain building, you have to providing the power in those kind of situation. So we were using the generator to handle that. This PowerPoint, they always put in few questions to ask you the things before. So the charging system, battery, and the load connecting in parallel with the rectifier power source is called D. So flow charger, right? As long as they can connect in parallel with the load, it's the floater charger. Good. If each cell is 3 volts, the voltage recorded by each voltmeter will be okay. One guy answered the B. Anyone else? Another guy answered the B. So B is the right answer. So I have to take A. These two is in offset, so 3 volts. B, these two in offset, 3 volts. C is these two offset, so 6 volts. D is cross all the way. These two cancel each other. These two cancel each other. D reads 3 volts. So B is the right answer. The internal resistance of a lead acid battery will be I think we talked about this yesterday, right? So what's the right answer for this?
B.
B? Yes, B is the right answer. What's the fundamental charging method used on nickel-cadmium battery? E, constant current. Good. How did you do? You got all the questions right? Then you're probably gonna get a pretty decent mark on this exam. No? Then you're gonna study harder. Otherwise, someone gonna getting hurt really bad. No, it's a smaller topic. Only 3%. For this 3% topic you think about, you got a 90% on this exam, you got a 2.7 marks. You got a 60% on this exam, you got a 1.8 marks. So it's only 0.9 mark difference. Okay, so any power system will always have an outage or downtime. When plan suffer from this, either level without or install equipment to shorten the length, especially those industrial plants, and you don't want to have a power interruption. So standby power system, you can have a dual radical feed, you can have battery and the UPS, you can have an emergency generator. Those one all have the advantage and the disadvantages. This is the generator. This is usually the battery with the UPS. This is talking about you have two sources. So if one source fail, they will try to maybe the hydro will give you kind of like a dual feeder. If one side is fail or out of service, you can connect onto another side to keep supply you. Or one more is you have an emergency generator down here, and you will use a bunch of a transfer switch to supply the load. So standby generator, they will use a transfer switch. The transfer switch is when you have the normal power supply, the transfer switch, everything's connect onto the normal supply. But when the normal supply fails, the transfer switch, automatic transfer switch, we have a sensor, voltage sensor inside, frequency sensor. They will check if the power is fail. They will send signal to start the generator, and after the generator voltage is stabilized, they will transfer this to connect onto the generator. So the load can still be supplied by the generator, but depends on what size generator you have. Mostly you're gonna supply essential load or critical loads. Unless you put in really large size generator, you can supply all the loads. Typical, it will take 8 to 15 seconds to bring the generator online. So because the generator needs starting, and after that, they still need to wait for the generator's voltage to get stabilized. Once the voltage is stabilized, then you will transfer your load to the generator, because the generator, when they first start, they will have a very low voltage, take time for the voltage to build up. Also, for the transfer switch to take the action to start the generator and to transfer over. So it usually take 8 to 15 seconds. The generator type, you can have a propane, can have a gasoline, you can have a diesel. The propane, and the propane generator is good, but propane is a really violent type of fuel. It will be kind of very easy to causing explosion and fire. That's one thing. So large storage of propane is really not advisable, and also the temperature the temperature, extreme temperature can cause a problem with the propane tank, those things. Gasoline generator, they will be starting pretty fast, but the gasoline, if you store them for a certain period of time, they're gonna be basically they become useless. Diesel, the diesel, you can store the diesel for longer than the gasoline, and they will still be able to using them. But the diesel engine usually starts slowly. So everyone have their own benefit and advantage and disadvantage down here. But most commercial backup generator, diesel is very common. Generator connection, large generator usually is three-phase, unless you buy a generator for residential single dwelling use. For any commercial building, the generator is always three-phase. The generator supply is always four-wire, three-phase four-wire grounded with a grounded neutral. So this is a very common one. 277 480 volts and 120 208 volts. It's also very common. Even 347 600 volts. That's pretty common type. Single phase. This is a generator, but this is a kind of industrial application. They have a three-phase delta. I hope you guys still remember this. Three-phase delta, then they have a center tab between, so this center tab down here. Which one in this situation is the high lag? I want to see if you guys still remember this. A is the high lag. So you can only center tab between B and C, right? So that will give you 240 volts for your three-phase, and you will have a 120 between B and the neutral and the C and the neutral for your receptacle or for your lighting requirement. Single-phase three-wire, it's it usually just used for the single dwelling. For the connection, I like to talking about a little bit here because this is an important thing you have to know. So we have a three-phase generator. We're gonna have a Y connection. The Y connection, we will have a higher voltage. We will have a lower voltage. So we're talking about multi-coil. You guys probably still remember this, right? The terminal will be labeled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for high voltage connection, you're gonna do is those are connect together. Those three connect together, those connect together, those connect together. If my line voltage is 600 volts, what will be the coil voltage here for each of the coil? So you're gonna figure this one out. I'm gonna make another drawing down here. The coil voltage, not the phase voltage.
$173 volt.
Yeah, so 173.5 volts, right? Because the line voltage is here, the phase voltage is 600 divided by root 3, 347. Two coil in series, each coil we have 347 divided by 2. Make sense? So this time we're gonna have a low voltage connection. For low voltage connection, we're gonna parallel them. We'll hook those together. So for low voltage connection, what is the coil voltage?
$374.
Can call it 347 or 346.4. We good? So this is a Y, and if we have a delta, have a higher voltage, or we can have a lower voltage. So high voltage always easy. Low voltage, line 600 volts. What's the coil voltage? What's the coil voltage down here? Delta is easy, right? Yes, no? Come on, give me a number, quick. Don't need to do calculation, you can just find the number. Or you guys all falling asleep? So 300 volts here, 600 volts down here, right? So between these four connections, series Y, parallel Y, series delta, parallel delta, you will encounter a question ask you to figure out, they give you a line voltage, you'll have to be able to figure out what's the coil voltage, or maybe what's the phase voltage. Were you able to do that? Yes? No? You don't care?
Yes.
Good. Travel, why I only got one good student in the class? Always answer my question. The rest of the guy all falling asleep.
No idea.
Yeah, so I gave you the drawing. You have to know them. It's important. Now I know sometimes students always tell me I'm writing too fast and they cannot take on. You guys okay with those four drawings? Anyone need me go back to show you the drawing or? Milan, you okay? Everything? So in series, there are two coils together. So delta, line voltage equal to phase voltage. So your phase voltage will be 600. You add them together. Same thing for here. Y, line voltage, your phase voltage in series, the two add together. That's why each take a half. Okay. So here's for the connection. Oops, too fast. Uh, 12 leads alternator to be wired use 4 conductor tach cable. If you desire the high voltage connection, how many split bolts will be necessary at this alternator termination box? Okay, I know it's close to the lunchtime. How about if you answer this question right, you can go for lunch. If you cannot answer this question right, that's gonna be your lunch time.
D.
Your lunch time is for feed. Yeah, if you get the wrong answer, you're not gonna go for lunch. So I want you guys punch your answer. So this is a Y connect alternator, and you're gonna go for the high voltage connection. how many split bolts you need?
C.
Yeah, if you punch your number, then I can see it. Then I can decide who can go for lunch, who cannot go for lunch. Justin, that's cheating. No lunch for you. Okay, C will be the right answer, right? Because you need to hook this one, hook this one, hook this one. That would be 3. You're going to connect all those 3 onto the line, and you need to make one junction connection in the center. So really hope you get that right. Yeah, C will be the right answer. Hey, smart class. Okay, you guys answered this question right. Should I give you 2 more minutes for lunch?
Sure.
Yeah, because sometimes a class always get more people get this type of question wrong. You guys are all good. So 2 extra bonus minutes for lunch. Only have 1 now. Okay, back at 11:30.